In this video segment, we're going to take a look at the second of the three major types of solution concentration expressions that you're responsible for knowing. As we introduced in our previous segment, there are three major expressions that you will be asked to show proficiency with. Mass percent, we looked at that in the previous video. Mass volume percent, which we are looking at in this video. And then in the next video in this series, we will be looking at molarity, the third and last of the three solution concentration expressions you're responsible to know. So let's turn our attention to mass volume percent, abbreviated M/V percent. And the definition of mass volume percent is grams of solute divided by milliliters of solution and then multiplied by 100 to convert it into percent. As I've indicated here, mass volume percent is very common in healthcare because of the prevalence of IV uses, where we're given medication in solution form and we need to know how many grams of the medication is dissolved in a given volume of solution, of IV solution. Let's take a look at two different mass volume percent problems. The key with all of these problems is to first of all be absolutely clear on the definition of what the solution concentration is. You have to have that memorized, no hesitation about using it. And then the second important thing is that you remember all of your dimensional analysis skills that you've used throughout the semester and be able to put them to good use in these types of problems. So let's take a look at the first of these example problems that I have written on the board. What is the mass volume percent of a solution made by dissolving 0.140 moles of iron 3 sulfite in enough water to make 500 milliliters of solution? Now notice what is happening in this problem. It's an integrated problem. You are given a mole amount, but the definition of mass percent is grams, not moles of solute, but grams of solute. So this has a mole conversion problem built into it, where you're going to have to take moles of iron 3 sulfite and convert that into grams. Notice that there is a nomenclature component as well. The formula of iron 3 sulfite was not provided, just its name. So you're going to have to be able to take that name and write the chemical formula based on your nomenclature skills. That will be necessary in order to come up with the molar mass of iron 3 sulfite that you need to go from moles to grams. So notice the connectedness of this problem. It integrates concepts that you've learned in previous chapters that you have to apply to this solution concentration problem. Hopefully it is not a problem to be able to immediately take the name iron 3 sulfite, and those nomenclature skills are right there at the ready for you, ready to be used, and you can write the formula Fe2SO3 parentheses 3. For the formula of iron 3 sulfite. And if you take that chemical formula and add up 2 iron, 3 sulfur, and 9 oxygen atoms, the atomic weights listed on the periodic table, and add those values together, you should come up with a molar mass of iron 3 sulfite of 351.9 grams per mole. So taking that information, reminding ourselves that the definition of mass volume percent is grams of solute per milliliters of solution, we can proceed with the dimensional analysis. Here is the mole amount of iron 3 sulfite, and if we take that mole amount and multiply by the molar mass of iron 3 sulfite, looking at our units, the moles of iron 3 sulfite cancel and we are left with grams of iron 3 sulfite, exactly what we need for the numerator of our calculation. Notice what I'm doing next. I am dividing, showing that as a multiplication by the reciprocal. I'm dividing by the volume of solution in milliliters. So there is no unit in the numerator. This is just a division by 500 milliliters of solution. So looking at the units that are left in the problem, that are not canceling out, I have grams of solute, iron 3 sulfide in the numerator, and milliliters of solution in the denominator, which is the definition of a mass volume percent. And then of course I need to multiply by 100 to convert that into a percent. So looking at my calculator and just running through this calculation one more time, always making sure when you are doing a calculation that you double check your work. I get 9.85%, and my answer should have, according to my setup, 3 sig figs. So writing our answer 9.85%, indicating that it's a mass volume percent, and the answer has 3 sig figs to it. Let's take a look at the second example problem with mass volume percent. And this question reads, how many grams of glucose are present in 0.750 liters of a 5% mass volume glucose solution? So you're given a volume of the solution and you're given its concentration as 5% mass volume, and you are asked how many grams of glucose solute are present. The key to this problem is being able to take that mass volume percent and write it as a conversion factor. That is absolutely key to doing this calculation, showing the correct setup. So whenever you're writing a percent as a conversion factor, you take the number and write it over 100. But it is very important that you label properly units and label or identity of what it is that you're referring to. So 5 over 100. This is a mass volume percent, so we have grams of solute, in this instance glucose in the numerator, and milliliters of solution in the denominator. Definition of mass volume percent. So taking the 5% and writing it like a conversion factor. We will need to use it in this form as a conversion factor, written properly with units and labels. We're told that we have 0.750 liters of solution, but our mass volume percent has milliliters of solution. So dimensional analysis skills come right into play here. We're going to take the 0.750 liters of solution and convert it into milliliters. Notice that I'm labeling that I'm talking about the total volume of solution here. Looking at the dimensional analysis, the liters of solution cancel, and we are left with milliliters of solution. Now we're ready to use our mass volume percent as a conversion factor, writing in its standard form. We don't need to invert. We want milliliters of solution in the denominator to cancel with milliliters of solution that we have written here in the numerator. If we stop our answer right now, we have grams of glucose showing in the numerator, which is what we are asked to solve for. So doing this calculation on the calculator, double checking our work. I have 37.5 grams of glucose, but looking at our setup, I see that our mass volume percent has 2 sig figs to it. The sig figs come from the numerator, from the concentration that's given. The 100 is exact. So 2 sig figs for our mass volume percent. Our answer should have 2 sig figs. So we will round up and take that 37.5 grams of glucose and express it as a final answer of 38 grams of glucose.